Good morning students. Today we are going to discuss about the factors affecting E1 and E2 elimination reactions. So now you know that what is mean by E1 and E2 elimination reactions and what is its mechanism, and you know about the kinetics and the evidences which proves the E1 and E2 elimination mechanisms. Okay. And the next topic which we need to discuss is the factors which affect E1 and E2 elimination reactions. Mainly these are the factors which affect E2 and E1 elimination reaction. That is nature of alkyl halide, nature of base, nature of solvent, and nature of alkyl group. Okay. So these are the factors which affect E1 and E2 elimination reactions. But these factors affect E1 and E2 elimination reactions in different manner. First of all, we will discuss about the factors affecting E2 elimination reactions. So you all know that E2 elimination reactions are bimolecular reactions, and it follows second order kinetics. And in this particular reaction, it is a single step reaction. That means the alkyl halide react with the base and form an alkene. In this case, the base attack the proton in the beta position, and the particular molecule will lose this proton, and we will get an alkene. Okay. And in this case, the nature of the alkyl halide will affect the rate of the reaction. And this alkyl halide must have a good leaving group. Leaving group means a halide ion in this case, because E2 elimination reactions we used dehydrohalogenation as the example. In dehydrohalogenation, the alkyl halides will react with the base. Okay, so this alkyl halide must have a good leaving group or a good halide ion to proceed with this particular reaction. Better the leaving group, more will be the rate of reaction. That means better the halide ion which is present in the alkyl halide, more will be the rate of reaction. And we can state the reactivity of the alkyl halide as alkyl iodide is more reactive when compared to alkyl bromide, and alkyl bromide is very reactive when compared to alkyl chlorides, and the least reactive one is alkyl fluoride. And the reason is that we can explain this with the help of the strength of a carbon halogen bond present in the alkyl halide. Okay, so the carbon halogen bond, if we consider the strength of carbon halogen bond, and in that case if we take alkyl fluoride, then the carbon fluorine bond will be strong, will be the strongest bond in this particular case. Okay, and the alkyl iodide, there is carbon iodine bond, and that will be the least strength carbon halogen bond. Okay, if we consider alkyl halides, the strength of carbon halogen bond is more for alkyl fluoride, because the carbon fluorine bond is very strong, but the least strength is for alkyl iodide, because the carbon halogen bond is very weak in that particular case. And this same statement can be used to explain the reactivity of the alkyl halide. Since the bond strength of alkyl iodide is very weak when compared to all other alkyl halides, the reactivity of alkyl iodide will be more, because there will be less energy which is required to break alkyl halide, the carbon iodide bond. Okay, so depending upon the type of alkyl halide we use for this particular reaction, the rate also will be different, because if we use alkyl iodide, then the reactivity will be very high, but if we use alkyl fluoride, then the reaction will be very slow. Okay, this is all about the nature of the alkyl halide. The next factor which affect E2 elimination reaction is the nature of the base. So you all know that the E2 elimination reactions involve a reaction between the alkyl halide and a strong base. So if it is a strong base, then the reaction will be E2 elimination reaction, and the function of the base is to abstract hydrogen as proton from the alkyl halide. So the hydrogen from the beta carbon atom will be eliminated when this elimination reaction or when this dehydrohalogenation is proceeding. That time the hydrogen of the beta carbon atom will be eliminated, and the function of the base is to abstract these hydrogen as proton from the alkyl halide. And because of this, the rate of the reaction depends upon the nature of the base. That means if the base is strong, then base has the power to abstract hydrogen from the alkyl halide very easily when compared to a weak base. So weak base will react with the hydrogen present in the alkyl halide very weakly. Okay, but if it is a strong base, then this strong base will abstract hydrogen as proton from this alkyl halide very fast. That means stronger base pulls a proton from the substrate faster, and if the stronger base is present in the reaction medium, the rate of the reaction will be more. Okay, like this nature of the base affect E2 elimination reactions. The points are: function of the base is to abstract hydrogen as a proton, and the stronger bases pulls a proton from the substrate faster, and that's why the stronger bases will increase the rate of the reaction when compared to a weak base. That means the stronger the base, more will be the rate of reaction. And the next factor is the nature of the solvent, and less polar solvents are used for E2 elimination reactions. If the solvent is less polar, then it favor E2 elimination reaction. And the last factor which we are going to discuss is the nature of the alkyl group. So now we were discussing about the nature of the alkyl halide. If that means if it is an iodide or bromide or chloride or fluoride, that was the point nature of the alkyl halide. Now we are going to discuss about the nature of the alkyl group, whether the alkyl group is tertiary or secondary or primary. Okay, these points will come under this particular factor, and in that case we should consider the reactivity of alkyl group. And we can see that the reactivity of tertiary alkyl group is more when compared to the secondary alkyl group, and the secondary alkyl group activity is high when compared to the primary alkyl groups. And this greater the stability for highly branched alkenes which is being formed from highly branched alkyl groups. And the reactivity we see it is tertiary is more reactive when compared to secondary, and secondary is more reactive when compared to primary alkyl groups. And because the greater stability of the more highly branched alkene being formed, that means if a highly branched alkyl group is there, then we will get a highly branched alkene, and the highly branched alkene is more stable when compared to less branched alkenes. So these reactions favor if there is a possibility of highly branched alkane formation, and this will be formed if we use the alkyl group with high branching. That means the more branching is there for tertiary alkyl group, and that's why if the alkyl group which we are using is tertiary, then the reaction will be more because the stability of the highly branched alkane is more. Okay, and The next one is the factors affecting even elimination reactions. So till now we were discussing about the factors affecting E2 elimination reaction. The factors are same, that is the nature of the alkyl group, nature of the base, nature of the alkyl halide and nature of the solvent. But how it affects the particular reaction, that is different. Okay. So in the case of even elimination reaction, the first factor which we are considering is the nature of the alkyl group. That means whether it is tertiary or secondary or primary. In this particular even elimination reaction also, the order of reactivity of alkyl group is same, because it depends upon the alkyl group. The tertiary alkyl group is more reactive when compared to secondary, and the secondary is more reactive when compared to primary. But the reason for the rate change in even elimination reaction, that is because of the difference in the alkyl groups present, the rate of the reaction in even elimination reaction changes. And this is because of the greater stability of carbocation being formed in the rate determining step. When we discussed about E2 elimination reactions, there also the order of reactivity was same, but we considered this as a factor because it increased the stability of alkene formed. That is, highly branched alkenes are more stable when compared to the other alkenes, less branched alkenes. But in even elimination reaction, this favor the rate of the reaction because greater the stability of carbocation being formed in the rate determining step, and the tertiary carbocation is more stable and it is produced by tertiary alkyl group. So if the stability of carbocation is more, then the reaction will go that side, or it proceeds to the side where the stability will be increased. And the tertiary carbocation is more stable and it is produced from tertiary alkyl group. And because of that, if we use a tertiary alkyl group, the elimination reaction will be or the rate of the elimination reaction will be more. And if we consider the nature of the base, as you know, in even elimination reaction, the rate determining step is step 1, that is the formation of carbocation. And in that particular step, base is not having any role. Okay, and that's why the rate of even elimination reaction is independent of the nature and concentration of base. And if the base is strong or weak, that is not affecting this particular reaction, because the base does not take part in the rate determining step in even elimination reaction. And the next one is the nature of alkyl halides. And in this case also, the overall rate of reaction depends upon the stability of the carbocation, and a reaction which favors the formation of tertiary carbocation will be more, because the overall effect is more for the tertiary carbocation, then comes the secondary one, and the first one, then the primary carbocation. So the tertiary carbocation is formed from tertiary alkyl halide, and if we use tertiary alkyl halide, then even elimination reaction rate will be more. Okay. The next one is nature of the solvent. In even elimination reactions, highly polar solvents favor even elimination reactions because it helps to stabilize the carbocation formed in the rate determining step. So in E2 elimination reactions, we use less polar solvents, but in even elimination reactions we use highly polar solvents because it helps to stabilize the carbocation formed in the rate determining step. Okay, these are all about the factors which affect even and E2 elimination reactions. Now we will compare even elimination reactions with E2 elimination reactions. Okay. If we consider even elimination reaction, it is a unimolecular elimination reaction, because in the rate determining step only one substance is there, that is substrate. But E2 elimination reaction is a bimolecular elimination reaction. That means in the rate determining step, two molecules are reacting. That means the substrate and base are reacting to get alkene. And in even elimination reactions, it involves two steps. The first step is the formation of carbocation, and the next step is the formation of alkene. Okay. But in E2 only one step is there, the bond breaking and bond formation and the formation of alkene, everything will occur in the single step. Okay. In even elimination reaction, there is a formation of carbocation intermediate, but in E2 elimination reaction, it is a single step process and there is no possibility for the carbocation formation. And the even elimination reactions depend only on the concentration of the substrate, and that's why we call these even reactions as first order kinetics reactions. But the rate of reaction depends on the concentration of substrate as well as base in the case of E2 elimination reaction. And in even elimination reaction, no need of strong base, because in the rate determining step, the strong base is not having any role. So if we use a strong base or a weak base, that doesn't affect the reaction. But in E2 elimination reaction, the strong base is required. In even elimination, highly polar solvents are required because it stabilizes the carbocations. But in E2, low polar solvents are okay. And in even elimination, there is no stereochemistry is required. But in E2 elimination reactions, the leaving group must be anti to hydrogen to be removed. Okay, so if it is in the anti position, that means in the opposite position, then the transition energy will be less. So this leaving group and hydrogen are placed anti to each other, then the transition energy to go into the transition state, for that energy will be less, and the orientations which helps in reducing the energy will be favored. That's why the leaving group must be anti to hydrogen to be removed. And in even elimination reactions, there is rearrangement of carbocations, but in E2 elimination reaction, there is no rearrangement of carbocations, because in this particular reaction carbocations are not formed. Okay.